Good morning to everyone. I am Preeti Gupta, Assistant Professor. Today I am going to discuss one of the important topic of design and analysis of algorithm, which is asymptotic notation. Asymptotic notations are one of the important topic of design and analysis of algorithm. Before going through the asymptotic notation, I would like to tell you the importance of asymptotic notations. Asymptotic notation is used to analyze the performance of the algorithm. It is basically one of the methodology to analyze the algorithm. There are basically three types of asymptotic notations. Asymptotic notation. First one is big omega notations. In big omega notation, I would like to tell you the definition of the big omega. There are basically two positive functions fn and gn. It is defined as big O of gn is equal to fn if there exists a positive constant c and n naught such that fn lies between 0 to cgn for all value of n greater than equal to n naught. In the diagram, you can also see the cgn function is a upper bound to the function fn when n naught is greater than n. Gn is an asymptotic upper bound for function fn. With the help of this diagram, you can also conclude that function gn gives the worst case complexity to the function fn because it gives the maximum time taken to solve a particular problem. When it takes maximum time to solve a particular problem, that means it is a worst case complexity to the algorithm. Next, the next asymptotic notation is big omega notation. The big omega notation is defined as big omega of gn is equal to fn when there exists a positive constant c and n naught such that function cgn lies between 0 to function fn for all value of n greater than equal to n naught. Similarly, with the help of diagram, you can also see that function fn gives the upper bound to function gn, or you can conclude that function gn gives the lower bound to function fn. That means function cgn is a lower bound, means it takes the minimum time to solve a particular problem. When it takes minimum time to solve a particular problem, so you can conclude that it gives the best case complexity to an algorithm. That means you can conclude this statement that gn is an asymptotic lower bound for the function fn. Next asymptotic notation is theta notation. Theta notation can also be defined as theta of gn is equal to function fn if there exists positive constant c1, c2 and n naught such that c1 gn and c2 gn lies of fn for all value of n greater than n naught. Similarly, you can draw the diagram of theta notation as we already drawn in big O notation and big omega notation. With the help of diagram, you can see that function fn lies between c1 gn and c2 gn. It means that function fn is asymptotically tight bounded between c2 gn and c1 gn. That means it gives the average case complexity to the algorithm. Fine. Now I would like to tell you one more important thing, that in big omega, big O and theta notation, we use the big name as the big omega and big O notation, but we don't use the name big in theta notation. Why? Because in big O and big omega, big O gives the maximum bound and big omega gives the minimum bound. There is two upper limit, big upper bound and big lower bound. That's why we use the name big in big omega and big O notation. Hope the asymptotic notations are clear to you. So now I am going to show the practice set of these three questions. With the help of these three questions, the theta notation, big O notation and big omega notations are clear to you. Now we are going to solve the question. The first question is 1 by half n square plus 3n is equal to theta of n square. First of all, I would like to tell you what is the meaning of the question. In the question, it is asked to you that prove that 1 by half n square plus 3n is bounded to n square. Okay. So, if in any question it is asked to you that some function is lies between theta notation, then you have to prove that it lies to big omega and big O notation, because theta is average case. Theta is average case. Theta is average case, and you have to prove that the big omega and big O. So you have to prove the average case, then you have to prove the big O and big omega. Fine. Let's come to the question. We have to prove the 1 by half n square plus 3n is equal to theta of n square. So, by the definition of theta notation, in the previous slide, we have shown that what is the definition of theta notation. So, by the definition of theta notation, you can write that 1 by half n square plus 3n lies between C1 n square and C2 n square. Fine. Now, this equation, this total equation is it shows the theta notation. What is the next step? The next step, we have to prove this lies in average case. To prove the average case, we have to show that it lies between big O and big omega. Tick. So, to prove that it is big O and big omega, we divide this inequality in two parts. Part 1, and in next slide we show you the part 2. Part 1 is this equation. Fine. C1 n square less than equal to 1 by half n square plus 3n. Now we have to prove this inequality for which value of C1 and n this inequality is true. We have to find the value of C1 and n for which it is true. Now we come to this equation. C1 n square less than equal to 1 by half of n square plus 3n. The left hand side contain C1 n square and the right hand side contain 1 by half n square plus 3n. So right hand side is always true for the minimum value of C1 is equal to 1 by 2. Clear? So now we calculate the value of C1. Now we calculate the value of N. To calculate the value of N, we check each value of N and find out the value of N. Now first we calculate N is equal to 0. For N is equal to 0, the equation, what is our equation? C1 N square this would be our equation. So for N is equal to 0, it would be 0 less than equal to 0, 1 by half 0 square less than equal to 1 by half 0 plus 0. So both left and right hand side is 0. For this value it is true. For N is equal to 1. Now we calculate for N is equal to 1. 1 by half multiplied by 1 less than equal to 1 by half multiplied by 1 plus 3 into 1. We calculate this value and we get 1 by half less than equal to 7 by 2, which is also true. Similarly, we calculate for N is equal to 2 and N is equal to 3. We see for all values of N is equal to 0, 1, 2 and 3, this equation satisfy. So we can conclude that for C1 is equal to 1 by 2 and N greater than or equal to 0, this inequality is true. Fine. So for C1 is equal to 1 by 2 and N greater than or equal to 0, this inequality is true. Now we come to the second part of this inequality. The second part of the inequality is 1 by half N square plus 3N less than or equal to C2 N square. Now before going to this inequality, we analyze something. Left hand side contain 1 by half N square plus 3N and right hand side contain C2 of N square. Left hand side is totally quadratic plus linear equation and right hand side has total quadratic equation. ठीक है. So to prove this, we have to show that at least 1 by half of N square plus 3N is less than equal to 1 by half of N square plus 3N. Fine. So in the next step, we have to make the right hand side is total or totally quadratic equation. Why it is required? It is required because in the inequality, the right hand side, the right hand part is total a quadratic equation. Fine. So it is required to make the right hand side as a quadratic equation. So what we do, 1 by half of N square plus 3N less than equal to 1 by half N square plus 3N multiplied by N. If this equality is true, then if we multiply it by N, then this equality must also be true. ठीक? So after what we get after calculation, 1 by half N square plus 3N less than equal to 1 by half N square plus 3N square, and the total value is 2 into 3 is 6, so 6 plus 1 7 by 2 of N square. So this equality 1 by half n square plus 3n less than equal to 7 by 2 of n square. ठीक है, which is अब now what is the value of C2? With the help of this we get the C2 value is 7 by 2. Fine. With the help of this equation, when we compare these two, we get C2 is equal to 7 by 2. ठीक. Similarly, as we done in the previous part for the value of n naught, similarly we calculate the value of n with the help of put the value of n is equal to 0, n1, n2, n3, n4 and similarly so on. And we get the for n is equal to greater than equal to 0, this inequality is true. So, we can state that 1 by half n square plus 3n square is big O of n square. Big O of n square because it gives the upper bound to the function of Gn. Fine. Hope it is clear. So, when the previous equality gives you 1 by half n square plus 3n is equal to big omega of n square, and the second part gives you 1 by half n square plus 3n is equal to big omega n square. With the help of these two equations, we can state that 1 by half n square plus 3n is equal to theta of n square. To prove the average case complexity, it requires to prove it lies between the best case complexity and worst case complexity. Hope it is clear. So now we come to our next question. Our next question is 10n square plus 4n plus 3 is not equal to big O of n. Now we have to prove this inequality that it is false. ठीक है? To prove this is false, first we assume that this is true. Okay, 10n square plus 4n plus 3 is equal to big O of n. So, first step is by the definition of big O, you can write this equation Fn is equal to big O of Gn as ठीक. By the definition of big O, you can write this equation as like this: 10n square plus 4n plus 3 is less than equal to Cn. ठीक है, यहां पर क्या है, ये है Fn और this is a Gn function. Fine. Now left hand side has a quadratic equation while the right hand side has a linear equation. So this inequality cannot be true. This value, this right hand side value cannot be greater than the left hand side value. So our assumption cannot be true for any value of C. So when our assumption proves wrong, that means this inequality 10n square plus 4n plus 3 is not equal to big O of n. Fine. Hope it is clear. Now we come to our next and last question. Our last question, what the last question says? The last question says the 2n square plus 5n plus 6 is equal to big O of n square. Similarly, as we have done the last two questions, this question can also be solved with the same steps. We compare this equation as Fn is equal to big O of Gn, and by the definition of big O of Gn, we can write this inequality. 2n square plus 5n plus 6 is less than equal to C of n square. Now, the left hand side has a combination of quadratic, linear and constant equation. This is quadratic term, this is linear term and this is constant term. While the right hand side has only quadratic equation. So, to make both sides similar means you have to, this is a quadratic equation and this is a combination of three equations. So, how right hand side become greater than left hand side? So, to make this inequality true, to make both sides similar, we have to convert left hand side as total a quadratic equation. To make this as total of quadratic equation, we multiplied n as required. What we do? We do 2n square plus 5n plus 6 and we multiplied with n as required, like in this term and in this term, and the total becomes 2n square plus 5n square plus 6n square, and the total value is 2 plus 5 7, 7 plus 6 13 of n square. Fine. Now this 13 of n square, the left hand side gives the 13 of n square less than equal to C of n square. Now we calculate the value of C for which this inequality is true. What will be the value of C? The value of C is at least 13. The value of C is at least 13 for which this inequality is true. Fine. Because हमें इसमें क्या करना है? We want to make this inequality true. To make this inequality true, we have to do some mathematical calculations. To make some mathematical calculation, we have to multiply it with value of n as required. In the previous example, we also multiplied with n in one term. So, as required multiplied with n, because this left hand side is totally of quadratic equation. How we compare these two equations? When these two equations are similar to each other. If this is quadratic equation, then it can also be a quadratic equation. Then can we compare these two values or these two functions. Hope it is clear. So, this is all about to my side. Hope it is clear to all of you. In the next lecture, I will discuss another important topic, that's master theorem. Thank you.